we are live. We're at the BICO shop. This is the live tour part of our class. We've got Dave here, George Shiflett. He didn't know he was going to be on it. He'd have worn a better shirt today, right?
Well, I brought him in at the last minute.
There you go.
That's
the best way to do it.
Any technical questions?
Yep.
Make sure I don't get in trouble.
Yeah, you don't want to say something you're going to regret later.
Exactly.
Right?
Yeah,
oh
exactly.
yeah, this will work like this.
Exactly.
So George is going to give us a tour of the shop. They've got things kind of shut down a little bit as we're walking through, but we'll be able to see the equipment and everything. So let's go ahead, George.
Okay.
Take
We'll
it
go
on
out. We'll go out here and we'll stop out front here and we'll talk about how our setup is.
Yeah, I'll listen to it.
As you can see, with all the racks, the pallet racks, and all the new equipment and everything, this facility here is BICO's headquarters. It's in Houston, and the way BICO does it is everything comes through here. Orders come through our facility, and we send it out. We do not manufacture anything, so most of it's done outside. So we place the orders to the vendors, orders come in, we QC it here, we stock it, and the districts order the parts from us, and we ship it from here to the districts. We have 5 districts here in the United States, plus Canada, Dubai, Saudi is online now, and Russia. We have a facility in Russia, or we have
facility, yeah.
people in Russia that service tools for us. But so we are international. So what we'll do is we'll start from here, showing the inventory that we have. We're gonna walk through here. At this facility, we have 2 breakout machines to where we service. While we are a district, we're also manufacturing. So we have 2 breakout machines, Griffith machines, that we service tools for the district, the Houston district here. Mainly that's for the south, but we service motors here for that. And then we also do R&D. We have a dyno area here. We do development on tools with the engineering group. So what we'll do is we'll walk through this area here and look at the receiving area. We have a rack set up for a lower end. That's a newer lower end that we have, and Dave we'll go through it and talk to you about the lower end. Okay, we can walk this way. As stated. Wow, wait till we get to here. We can come over here. Normally, you know, the lines are cut off, and we don't allow people walking through here. But we're going to shut people down as we go in the area. Normally, what we do is, as stated, equipment comes in, we check it in, we QC it. We have a QC area. We'll do this first, and then we'll go to the QC area and show you some of the things we do in the QC area. So this is this part over here. This is part of a mud lube lower end that we build. It's BICO's design. This is a 5 1/4 tool. We have options for the tool to where we can run a articulated claw shaft for a shorter bit to bend, or we can run a flex shaft for a lateral or longer bit to bend motor. So this is basically, if you look, 5 1/4 tool. This same part for our 9 and 5/8 tool. So quite a bit of difference. Anybody in the industry, that kind of looks like old pup joint from or a 10-foot collar, pony collar.
It'd be an expensive pump.
Yeah, yeah. So what we're looking at, just so we can go over a mud motor, for a lot of people don't know exactly what we're talking about. You know, you have for a mud motor, you really have 4 different sections. You have your top section, which is basically a float valve or to allow the fluid going down through. Then you have your power section where the fluid pumps down through, and from there you have your transmission, and then you have your lower end. Your lower end consists of your drive shaft, your radial bearing, I'm going to pinch myself here. Your radial bearing goes here. And for most mud loop bearings, you have a lower radial bearing. Then you have a upper radial bearing, which would be say this section here will be your upper radial bearing. So the purpose of the lower radial bearing and the upper radial bearing, we'll see a rotor and stator here in a little bit, but for the purpose of this radial bearing, it takes it from when you have a 5/6 lobe stator and rotor, when the inside is turning, it's turning not centrifugal, right? Is that right? Not centrifugal. So what the radial bearings do is they bring it back down to where it's turning centrifugal. You have a lower radial bearing, upper radial bearing, then you have a set of axle bearings. I don't have the balls on me, but you have a set of axle bearings that go in the middle. And the axle bearings, when you put it all together and you do compression, it allows you to have some give in there so it's not stiff. Right, Dave? Mm-hmm. So it's not stiff, and it allows you to have some bounce in there so it's not, if it was stiff, if the axle bearings weren't in there, you know, it would break. So the axle bearings allow it to have some give in it. So what happens is, so you have your lower bearing assembly. Your lower housing consists of different types of material. This is a tungsten carbide insert. Same with your lower male. That there's a certain amount of clearance in there, so fluid goes through to cool the bearing. So coming out of that, your drive shaft, what I call the drive shaft, coming out there, it's attached to the flex shaft. We'll use this as an example. Attached to the flex shaft, where it has your radial bearing on it, your upper radial bearing. The top of that is attached to your rotor that's coming out of there. The reason why it's called a flex shaft is because it has some give to it to allow the torque to go through without breaking it. It's not stiff, it's flexible, hence the word flex shaft. So basically, the mud motor, everything that you see here, from here, this is turning, that's this hooked to the bit, this turns, the drive shaft turns, everything else, when it's attached to the OD of the motor and they're going down hole, it basically stays stationary. It doesn't turn. The inner The inside is what's done all the turning, and it slides as the bit is turning and drilling, fluid's going back up the outside, and so they're pushing it in the hole as they're drilling. So as they're doing this, to have 3 points of contact, or to keep it off of the wall as they're drilling, you have a fixed pin that has your bend in it for your angle, but it also has a pad on it. It's a hard metal pad. This is a PPA pad that's on here to keep it off of the wall of the hole. Right? So in this case here, like I said, we set up here, we have a shift to bend motor, which has an articulated transmission. That allows you to get more give, more free in a shorter span, in a shorter distance. Okay? So, in order to use this, in order to make it shorter, you want to use an articulated transmission. For a lateral motor, you would make it longer, and you can use a flex shaft, which is stiffer, lasts longer, more durable.
Hey George, we have a question. So what's the function for the upper bearing and lower bearing?
Okay, so the upper and lower bearing, the function of it is to keep the pressure off of your axle bearings that are, your ball bearings that are in there. So it keeps the pressure off the axle bearings, but you got to also have the right amount of gap in there in between the bearings to allow the fluid coming through. So if you look at it, you're pumping fluid down through your power section, down through your tool, okay? So if you look at this, here, say for instance, this flex shaft is attached directly to your drive shaft, correct? So if you look at this flex shaft, it has holes that go through your flex shaft and down through the center. If you look at your drive shaft, it has a hole that goes down through here. So what you want to get, and by the gap in your radial bearings, upper and lower, you want a certain amount of fluid going as you're drilling. That fluid pumping, it's coming out of the stator, coming out of here, and it's going around your axle bearings to keep this cool, to keep your axle bearings cool, and also to keep these cool. Probably 10 to 15% is going over your radial bearings to keep them cool. 85 to 90% of the fluid is coming out of these holes here, going down through your drive shaft and down through your bit. That's where the bit has the jets in it and washes the mud back up the anglers of the tool. Okay?
And then this bearing material, what is this? Is a diamond?
This is a carbide insert.
Carbide inserts.
If you look at the market today, this is probably one of the biggest ones out there. They have spray on. They have different applications.
Yeah.
This type of carbide insert, I mean, this is a very durable insert, and that's why they get used.
So you normally have to change this out after every run?
No, these are pretty durable. These here, you know, I don't want to give away how many hours or whatever we get on, because we do better than everybody else.
Yeah,
so
it's everybody else plus.
yeah, everybody else. But you can run them over and over.
Right.
You can run them as long as the clearance, like I said, you check your clearances, because you don't want, if they're too big, you're putting too much pressure on your tool. You're not getting your build up rates that you want. But you also, get too much fluid going down through here. And depending on the application, you don't want that much fluid going. You want the fluid going down through for your bit, you know. So
yeah, that must be the alarm. You're giving away too much information.
That may be. That may be. That may be. So I mean, we put this up here so we can show the size. If you're looking at the 5 1/4, if you look at the 9 5/8, sheer fluid that goes down through there, them holes and the bearings, how big this is. I mean, it's like 4.5 IF connection. I mean, I've never seen anything like that. I mean, this is just unbelievable to me. Been in business for a long time, and that's huge no matter who you talk to. So as far as the lower ends go, like I said, you have stabilization to where you have your bit, you have your stabilizer on your bearing, and then you have your kick pad. All that keeps you off of your wall to keep you from sticking to your wall. Sounds good. Anything, Dave? Have any more questions? Alright, so we'll walk over here and we'll look at the QC. We'll look at one of the things that we do for angle. Each one of these fixed bends has a certain degree of bend on it that will allow you to either build or drop angle depending on how they turn or which way they want to go. That will allow you to build or drop angle. This one here is a 2.0. We measure them every time when they come in. There's certain criteria that we go by, but and I think he's measuring one over here now. We'll look at that, and then we'll look at the power section. Hey. Hey, go tell Fidel, come here. You want to just put your thing up there and show them? Yeah. Okay. Just real quick, show them. This is how we measure. You don't have to do it real fast or anything. I mean, real thorough. Just real quick.
It's my center finder. I got it set at 0 right now. So it's at 0. Get my digital protractor. I'm not gonna be able to see that.
So this gets checked whenever it comes in new. Gets checked after every run. It gets checked after every repair. It constantly gets checked because you know you're always going to have the yield. You know, you're always going to have to where it started out as a 2.0 and it starts to drop. So you got to have that idea.
Somebody out there with a hammer trying to straighten it out.
Exactly.
So I set this at 0. This is actually my straight. And this is where the angle's made. Set that at 0.
So like I said, there's criteria on what it can be. You know, we give ranges that where it could be because like it does drop some as it goes. But what you're looking, this part here is part of the transmission. It covers your flex shaft, right? And it's what connects your power section to your lower end. So the dual application.
You're not allowed to lean on this table too much.
Yeah. Watch your feet here. This thing's up here. Watch your feet. these are, when I talk about the stator and rotor, you have a power section. This is your stator, this is your rotor. These are contoured cans. I don't have a little thing with me, but the contoured cans have basically, they look kind of like the outside of the rotor on the inside. So the rubber's a little thinner in here than it would be a conventional can. But if you're looking at it, there'll be one more. If you count this, there's one more of these lobes in the stator than there is in the rotor, which allows the fluid to come down. As the fluid comes down, the open chamber that is there is what goes down through and it turns the rotor. So like I said, this is part of the tool that they're pushing in the hole. As they're pushing down through the hole, the mud is pumped down through and it's turning the inside. So your transmission or your flex shaft that we talked about is connected to your rotor. Your rotor's connected to your, on the other end, it's connected to your bearing assembly. So as you go, a complete motor is, you're pumping the fluid down through there, it's turning, and if you can see with these different lobes, as this is coming out of there, it's turning like this. And that's what the radial bearings do, is bring it back down to centrifugal to keep the pressure off of the parts in the inside of the tool. Basically what it is. You have different types of rotors that are carbide. You have carbide that are for offshore or for high chlorides, or you have carbide surfaces, and for hotter hole, when you go in these hot holes, you have chrome, which is a softer material that you want to run chrome. Now you want to be careful mixing them up, because if you run carbide in a hot application and the rubber swells up and it's hot, carbide is harder, so it wears out your power section, wears out your rubber faster. So you've got to make sure that's one of the biggest things, is knowing your application and putting the right equipment into your hole, into what you're doing. That's one of the biggest things. So we have different sizes. I was getting a flashlight, but I don't know that you can look in there and see with that camera. You want to give it a shot? Why don't you see if you can look up in there and see if you can see that rubber in there. So as I stated, one of the things with that we have, here we go. When I say there's a contoured can, if you look out in the industry, you got cans that are not contoured, and then you have cans that are like this. A can that's not contoured, these will be out, and the rubber's thicker in there, and it's like a tube that's solid all the way, and then the rubber is thicker in there. The rubber on these contoured cans are thinner. The torque is more because of the how these lobes are inside is stiffer, and there's less rubber in there, so it doesn't swell up as much. But you have the torque because of the lobes that are in there. So really good product. Everybody should use it.
You are allowed commercials.
Yeah, that's right. Everybody should use it. Best on the market. Unfortunately, when setting this up, I did not set up a complete tool. Looks like I have some over there that we can go over there and look at it. You got to watch your feet, and we'll shut down everything and let me, let's go over that. Hey, can you do me a favor real quick? Take the crane and put the, put that one of them 4 3/4 on the outside so we don't have to walk on the other side. So one of the things I talked about having 4 pieces. You have your top sub, which is your float valve that controls the fluid that goes through. When you cut off the pumps, the float valve shuts off and doesn't allow the fluid to come back through. The other thing that goes into that section at the top is a rotor catch. So we have a design where the rotor catch goes into the top of the rotor, and it has a sleeve on it, so if something were to happen downhole, then it would catch on the top of that, on top of the metal top sub, and allow it to where you can get it out of the hole. So you have 2 different catches on this motor, one in the bearing pack and one at the top of your rotor. So hopefully if we identify an issue fast enough, we can get it out of the hole. That's the key though, you gotta identify it fast enough, because if you don't, it will wash out. You know, if you pressure up and you don't see it fast enough, it will wash out that ring and nobody's gonna get it out. So, but if you see it fast enough, it works. Hey, sir. Sir. So as we look at this as it's complete, what I was talking about, you have your top section that has your float valve in it, and also has your rotor catch in it to keep it from if something happens. You have your power section, which is your stator and rotor that we just looked at. You have your transmission, which is the fixed bend, which gives you your one point of contact, and it gives you your angle for, depending on where you want to go, the hold angle, the drop angle, or like I said, in short bit to bend, you can go to a higher angle to go through your curve, longer bit to bends, and mainly normally for laterals. But so, and then your bearing housing and your drive shaft. Bit goes on the end here. As stated, they pretty much push this through the hole as they're drilling, and they, if they get, they're looking at their equipment and they're off, they can stop pumping, rotate it, get where they want to be with that angle, and keep drilling.
George, there's a question about the advantages and disadvantages of adding stages to the rotor.
Awesome, I'm so glad you're here.
Let me just step back out of the way.
So the more stages, the more pressure you can develop, and the more pressure means the more torque that's applied to the rotor. So the advantage of more stages is you get more power, in a nutshell.
I just want to make sure I didn't say something wrong. I know you can, the less lobes, more speed. More lobes, less speed.
Correct.
Higher torque, right?
Yeah.
Less lobes, higher speed, lower torque, more lobes, slower speed, higher torque.
Correct. Okay, that answered the question.
That answer?
Yep.
All right.
Pressure's
So
off.
as I talked about the two torque machines that we have, they're both Griffith machines. And I'm doing some more selling. I don't mean to, but that's what they are. We don't get anything out of it but hard work.
Yeah.
But if you want to do volume, they're good. It's a good tool. So this is basically our shop. We do, like I said, all the QC for new stuff is done in this area over here, but we do QC for used tools or for engineering design, or we do R&D projects. Everything's done over in this area for that. We have a third-party inspection that's here all the time. We do not inspect our own equipment. When I say inspect, I mean non-destructive testing, mag particle, dry penetrant. We do that on all of our tools, but it's done by a third party. So we don't.
No conflict of interest.
No conflict of interest. Thank you, sir. No conflict of interest. So that's about it. If nobody has any questions, that's all I got.
Yeah, I just asked if anybody had any more questions, and no response as of yet. So,
Okay.
George, appreciate it. Thanks very much for the tour.
You bet. You
Thanks
bet.
to
I
BICO,
hope-
Dave.
Hopefully
Thanks.
it went okay.
You done good.
Maiden voyage on this, I guess. So
Yeah.
hopefully it went okay.
Honestly,
And
it seems like it did. We had peaks from around the world looking in and so
Okay,
forth. So
good,
that's a good thing.
yeah,
And hopefully we can do this again sometime. Appreciate it.
sounds good.
All right,
Anytime.
thanks everybody.
Thank
Signing
you.
off now from Houston, Texas. Take care.